Okay, I think that we can start. Let me again introduce myself. I'm Enrico. I'm the general manager at RF Systems. And today I'm going to present you the webinar about radio frequency drying. So, which is the reason to discuss about this, why it is important a webinar about this. First of all, for food and safety and quality. Through this technology, you can increase the shelf life and reduce the checking problem of your production. You can shorten the time with the process optimization and the workflow. And you will see that there is also a cost reduction connected to the energy saving of this technology. In our webinar, we will discuss about these topics. First of all, I will like to introduce you RF Systems. Then I will like to explain you how the radio frequency technology works and compare it with other conventional technologies. We will speak about the advantages of radio frequency drying, and in the conclusion, we will then try to answer all of your questions. I hope many. So let's start introducing RF Systems. It's an Italian company. I'm speaking from our offices, which are based in Vicenza, 1 hour drive from Venice Airport, north of Italy. Our company was established back in 1991 with over than 1,000 systems sold worldwide, and we do heat treatment systems for food and agriculture products. Here on the right, you can see some application specifically for drying in a bakery, for cookies, snacks, and in the lower left corner, sponge cake, for example. Before starting to discuss the advantages of this technology, I would like to explain you what it's about. And starting from a very obvious consideration that all of you know, every kind of food, in this case we're talking about bread, has water inside. And as you know, the water molecules are like magnets. They are dipoles because they have a positive and negative charge due to the hydrogen and oxygen atoms. So in any kind of product like bread, we have water molecules inside. And they are randomly oriented until we put electric field, and under the electric field, the water molecules will orientate, will follow the field. So as you can see, the negative part of the molecules will follow the positive, and the positive will follow the negative. So this is what happens when you put any kind of food inside an electrical field. Now, in our systems, the electrical field change polarity 27 million times per second. It means that we reverse the polarity each second, 27 million, and this creates a continuous rotation of the water molecules. And by this rotation, we create heat. So it is an internal way of heating up a product. As you can understand, the heating is created internally, independently from the volume, the thickness, the temperature, the composition of the product. As soon as there is water, of course, this technology heat up the product internally. Before we go on, I would like to assure you that this technology is not dangerous. Here, you can see the spectrum of the radio frequency. You start from very low frequency up to the ionizing frequency. And as you can see, the 27 megahertz is in the lower part. We are way below the microwaves frequency, way below the infrared and visible light. So, as you know, only ionizing radiation like X-rays and gamma rays are dangerous for the for the body, but it's not the case of our frequency. And here below, you have also the link to the Food and Drug Administration that consider this technology a normal heat process to be applied to food. So you don't need any certification or any kind of special requirement to use this technology. I now would like to compare and to explain you why radiofrequency drying is so different from conventional heating. In conventional heating, you have exactly the opposite. The heat is transferred from outside to inside, and therefore you don't achieve a, let's say, uniform heating, and therefore it's almost impossible to have a uniform heating. Think about a typical product that all of us knows, bread. Bread is very well cooked outside and it's very soft and humid internally. Sometimes in some application, you want to dry internally and to have a more uniform humidity. So with conventional heating like gas oven or infrared system, you have the disadvantages that the heating and the drying is not uniform, first of all. You can have this effect of browning at the surface because you are overcooking the product in order to reduce the humidity internally. This is what happened with bread, for example. And internal water means bacterial proliferation, so it's not very good for the shelf life and safety of the product. And again, speaking about bakery product, for example, you will have tensions between the surface and the core, which at the end will create some quality problem like cracking of the product because of these tensions. So this is of course the common way to dry and to eat food, but these are the main disadvantages in conventional heating, again, from outside to inside. There is another technology, which is a microwave, that use a generator called magnetron, through a waveguide, a kind of metal tube. The electromagnetic waves are injected from a single point into the chamber. The product in everybody of you have a microwave in your house, you have a rotary plate. Why? Because the rays are spread randomly in the chamber and they bounce between the product and the chamber. And so not only the product is heated, but also the metal shell, as you can see in the red underlined part. So you are dissipating part of the energy in the chamber. But then, due to the lower penetration of the microwaves, you have the product which is heated up and dried more on the surface, like in a conventional oven, rather than in the center. So even with a microwave, you can have these disadvantages. You can have less penetration of the waves because they are shorter, and so less uniformity. You can have a hot spot on the surface because it's heating up more than the center. And you have energy dissipation because, as I explained, part of the energy is reflected into the metal chamber. Well, let's see what happened in a typical radio frequency system. You have a conveyor belt, the product is on the conveyor, and the electrical field is applied to electrodes which are above and below the product. And therefore, all the product is passed through the electric field, and all the water molecules inside the product will rotate, and therefore you will have a very uniform heating and drying of the product. And at the same time, you are not dissipating energy into the system. If you touch the conveyor belt, which is in plastic, or if you feel the air inside the machine, it is not heated. So all the energy will go only to the product. So just to recap, the advantages of radio frequency drying are that you can achieve a very uniform drying, very fast, and fast means also that you are protecting the quality of the product. You are not prolonging too much the high temperature. So you achieve the same result in a shorter time, therefore keeping the quality of the product. And it's a very efficient system because, as I told, first of all, we're not going to use fossil fuel, and secondly, we are not dissipating the energy heating up the ambient, the air, or the machine. Here I try to compare different systems to the radio frequency technology. On the horizontal axis, you have the process time, the drying time, and on the vertical axis, you have the drying quality. So you can have a process which is very slow or a product which is very fast. The process can give you a non-uniform drying or a uniform drying. So let's try to map the different systems in this diagram. First of all, let's speak about external heating. In many agricultural commodities, as you know, the product is heated just with the sun. Think about coffee beans or cocoa beans. So there is a natural drying which is extremely low and not uniform. Then you can use ovens, like in the bakery system or in other food industry, or you can use infrared. In any case, these processes are quite slow compared to internal heating, which is the other family of technology. And in any case, you will achieve a dryness which is less uniform and in a longer time compared to the internal heating technology. And there are two of them. One is the microwave, which for sure is the fastest, is a very, very fast, faster than radio frequency, but is less uniform, as I explained you before, compared to radio frequency. So the winner, I would say, is radio frequency drying in order to get a product which is uniformly dry and with a very short time. Which kind of food can we process with this technology? And which kind of other application we can apply with this technology? Well, we are talking about drying, but just for your knowledge, we can use the same technology to obtain pasteurization to prolong the shelf life of the product. Basically, the machine will be similar, but we'll have to add, for example, a maintaining tunnel to keep the temperature of the product to pasteurize it. Or we can have another application for defrosting, which is used, for example, for meat defrosting. So with this technology, keep in mind that we can not only dry, but also pasteurize, also defrosting. Of course, not with the same machine, but with different configuration of the same technology. Here in this picture, and even on my back, you can see the image of the typical radiofrequency inline conveyor system, where you have a belt where you place the product. The bulky central part is the generator, and in the tunnel you have the electrode, and the product will pass through the electrode, heating up like I explained you before. Now, talking about drying, you can use this technology for baked product, but also for candies, confectionery, for cereals, for legumes, herbs, and even for pet food. So there are many applications where you can use this technology. Now we will see which are the advantages of radiofrequency compared to other conventional technology. First of all, you have a strong reduction of surface browning, or you avoid to have the surface which is too dry compared to the core of the product. In bakery, you also reduce the acrylamide deformation, which is a toxin, and by 50%, for example. Because it's more uniform, like I explained before, you reduce the tension between the surface and the center, and therefore you reduce the breaking of the product. And beside, in the conventional technology, you have fragility due to non-homogeneous drying, and you have cracking and checking problems. You have a product with improved quality because thanks to the fast treatment, you preserve nutrients and like vitamins, for example, and you improve also the radiation after, because the product is more homogeneous. You can have a better texture and color because you avoid the browning. So you improve the quality of the product. In the conventional technology, because it's a very long process and with a high temperature, you can lose thermolabile ingredients, and you can have surface browning and worse rehydration property. You reduce the drying time. Think about drying cocoa beans or coffee beans in the sun. You need days, maybe not hours. And with this technology, you can dry even agricultural commodities in minutes. I already say that you can achieve a very uniform drying, and with the conventional technology, the product heat ups and dries from the outside inward. So you have a different, let's say, a percentage of water into the product. You also can reduce the space because this technology is much, let's say, shorter in terms of length than traditional technology like hot air system that require a very long tunnel. They said there is no heat dissipation, and therefore it is a very efficient technology. And as I mentioned, you are not using gas burner, for example, so it's a green technology. Let's see some example from a case history. Drying cereals bars with variable electrical field. In a conventional system on the right, you can see a very long configuration of a typical a gas burner oven. And here you have the product which goes out at 10 to 13% humidity, internal humidity. And as you know, it's very difficult with a traditional oven to control the final humidity. Even, for example, think about when the humidity change during the day. And in this case, the feed rate was 1.5 tons per hour. And the challenge was to have a post-baking application with internal humidity up to 6% with a very small tolerance. And we achieved this with this advantage, reduce the space from many meters to only 6, reduce the acrylamide deformation, so reduce the browning effect on the surface, reduce the defective product, and save energy cost. So this was, and it is a real case from one of our international clients. We have many other example. For example, here, this is an example of biscuit. Even here, you can understand how difficult it could be to dry internally without overheating and without, let's say, overcooking the surface. Beside, on the left, you have the oven. On the right, you have the radio frequency dryer. You can extract the vapor from the product easily with this technology. This is an example of crackers. Here you have on the left snacks, and but you can also have fruits, herbs, vegetables. In this case, it is candied fruit. We do have a lab in our company where we can do all the tests with your application. And I will share with you some example that we did for our clients, starting from bread loaf. You can use the same technology for crusted loaf bread. And in this case, the input moisture was 18%, and the target was to reduce it at 2.5%. And we achieved that in a 2-minute cycle. Of course, in this case, we are talking of a product which is very porous, and as you can see, the conveyor is a mesh. So we help the drying also with the air circulation, hot air circulation. But in this case, there is a good reduction of humidity, very precise at the end, with a very short treatment. So, for example, for those of you that have a product which need to be consistent in color, think about, for example, white crustless loaf bread. With this technology, you can even cook directly the bread with a radio frequency system without using a traditional oven. This on the right is an example of agriculture commodity. This is raw rice. And you see that the treatment time is longer than the first example. Why? Because you can understand that here you have raw rice and it's not so porous. So you need more time and more treatment to evaporate the water. here on the left low corner, you have another example where the moisture reduction is very limited. I wanted to show you this example, sorry, on purpose, because you can understand that this is mint candies. Mint candies are not porous at all. So, of course, the let's say moisture, humidity, evaporation will very depend on the kind of product that we treat, and each one of them will respond in a different way. But here, for example, you can see a good moisture reduction, 20% in the same time range in 20 minutes in pet food. This is extruded meat. I think it's poultry meat for pet food. So, as you can see, different product from different food industry, and with different result, and we have many examples, and I really invite you to, if you are interested, to use our lab to send your product. So before passing to your question, I would like to conclude and to remind you that this technology will help you to extend the shelf life of the product and also increase the quality in terms of more uniform heating, more uniform color, texture, preserving the nutrients. So a lot of advantages in terms of quality, but also will allow you to shorten the process time and also the requirement of space dedicated to the technology, and also will allow you to increase the yield, reducing the waste product, the defective products. So the next step, as I told you before, I invite you to send us your sample for testing so that we can check and see how we can help with this technology. Now it's time for you, for your question. I will switch to the web call mode and look at your questions. Let me reach them. Okay, the first one that I see is fungal growth is common when drying products such as corn. How does the radiofrequency system reduce or eliminate fungi? Thank you for this question, because next webinar I'm going to prepare is about pasteurization. So you can use this technology to increase the, let's say, safety of the product. And as I said before, we have to add to the normal configuration also a maintaining chamber, where after heating up the product, we keep the temperature for at least the same time. And we have made different microbiological analysis, and I confirm you that we can reduce fungi, mold, bacteria, and so we can really use this technology also to this purpose, and it's a pasteurization and sanitization application. The second question is how much water is possible to evaporate per minute. Okay, this is a very good question. As I explained before, it very depends on the structure, on the texture of the product. Okay, they tell me that the audio is not good. I try to, let's see if I can put at maximum the microphone. Okay, I hope it's better. Okay. So I was answering the second question about how much water is possible to evaporate. It very depends, as I said, from the texture of the product. Before I show you different examples from loaf bread to mint candies to rice. So let's say that it very depends on the, but there is not an average question. Okay, let's see if I see some other question in a DNR. Okay. Okay, there was a second part of the question. How can we avoid electrical arcing during RF drying when we have high moisture content? Yes, we have an arc detector system to avoid this. Of course, we have to do the right recipe for every product. The machine has a PLC, and we have to control the, let's say, timing, the distance of the electrode, the power applied in order to avoid arcing. And if arcing happen, we have an arc detector system. But of course, this very depend on the water content. So we also have in the machine fans to evaporate and to extract the vapor in order to avoid this side effect. There is a question about the size limitation for electrodes. Well, let's see that we have a different system and that have, of course, different production capacity, and the limitation is due, let's say, to our actual range of machine, but I wouldn't say that there is a physical limitation. Another question is, what impact does RF drying have on the shelf life and freshness of bakery products? As I said before, we can also use this technology to the shelf life of the product, because we achieve let's say more uniform humidity, and in some cases is the only way to reduce the internal humidity. And as you know, humidity is linked to bacterial proliferation, so indirectly we prolong the shelf life of the product by drying. But then we have also another configuration of the machine when we can really do a pasteurization treatment. And instead of using, for example, a traditional oven, when in order to pasteurize bread, you have to leave the product for probably 40 minutes at 80 degrees. Here we can really treat the bread in a few minutes and with a thermic shock, and preserving the, let's say, the freshness of the baked product. Let me check other question. How does RF drying impact the overall quality and consistency of the final product? Yes, like I said before, first of all, remember that with this technology, you avoid the overcooking of the surface, so you get a better color, but also you get a better texture, because the humidity is more uniform. And for example, if the product, like in the let's say example of a vegetable of herb, must be then rehydrated, we have a more, let's say, uniform structure, so it's more easy to rehydrate. types of material are best suited for drying technology. Depends, of course, must be water inside, so any kind of food product. And then I see, can RFID technology be used for fried products like potato chips? If you mean to dry, I would say that we have to test. But if you mean if you have to dry to fry, this is not a cooking technology. Okay, let's see if I have left because there are two ways to put the question. Okay, there is a question about how many kilowatt hour of electricity is used for every kilogram of water evaporated. There is a proportion about 1 to 1, 1.2 kilowatt per hour per liter, but it very depends on the product. Another question is about the average size footprint of an RF dryer compared to the microwave dryer. Let's say that the two technology are similar in let's say about the dimension, but are different in terms of quality, like I explained before. I think I answer most of them. Let's see if I'm able to. In any case, okay. In any case, I strongly recommend you, if you have additional question, to write me and or call me. I will be willing to answer your question. And here you have my my email. Here below you can find our telephone number. You can also join me through LinkedIn. So once again, thank you for joining this webinar, and keep in touch. We will send you this presentation after the webinar. Thank you.